Degrees of polynomials. I would like you to turn and talk to the person closest to you. If you do not have someone sitting next to you today, you can turn behind you. So Ben and Finn, partner up. Tell them for each one of these, what are the degrees? I'm going to call on some random people. How about India? What's the degree of the first one? Yes, 5th degree. Very good. And right now we're just doing the degree. We can name it if we want. I might do that. It doesn't say to name it, but just to help us remember that further, we do have that poster up on the board. This is Kintic, is what we say. Okay, next. Did I spell it right? Yeah. Sophic, what's the degree of the second one? Yep, 1st degree, which is linear. That would be a line if we were to graph it. Sarah, what is the degree of the third one?
0.
Nice. Let's see, who do I want to pick on next? Pay attention because this one's a monomial. Finn, you got this one?
Yeah, it's
What?
the 11th degree.
Nice. Which we do not have a fancy name for. We're just going to say 11. Because what we do remember is we add these two because it's a monomial. So we would have done the same thing up here, but we only add the exponents of the variables, remember? So this only has a variable of 1. 5 is not a variable, so you don't add it. But for that one, there's 2 variables. We add them up, we get 11. Okay, and then the last one, how about Stevie? Yes, and do you remember the fancy name for that? Yeah, quartic. Oh, how about Ben for the first one? What is it called?
It's polynomial and it's quartic.
Quartic, yeah. So I'm going to say quartic polynomial because remember when it's 3 or more terms, we have it on the poster up there, we just say polynomial. Now, if you say 4th degree on a test or a quiz, I won't dock you for it, but this is a good one to know. You might as well know quartic. It's not going to hurt you. Next one, how about Bella? 7 plus 5x. What's the degree and what's the number of terms? Linear, because it has an exponent of 1. Binomial, yep, 2 terms. Xander, you got the last one?
Mm-hmm. Quadratic trinomial.
Yes, that is my favorite as well. This is what we deal with the most in this unit. And really this semester, we're going to be doing a lot of quadratic trinomials. And binomials, I suppose. Next one, simplify the expression. You see a subtraction sign in the middle. Remember, we have to distribute that. So I would distribute that first. And then let's bring this down. Does that look right? Okay. Then we just combine like terms, right? This looks bad over here. This is a 6b squared, in case we're confused. Okay, we got 4b to the 4th and negative b to the 4th. So how many b to the 4th do I have? 0. So let's not write anything, but I could like cross them out to show, hey, you already did those. How about b squareds? Negative b squared and positive 6b squared. What do I get, Nancy?
Wait, sorry.
Yeah. And then we got negative 3, negative 1. So I get what, guys? Bingo. Let's go ahead and name this while we're at it. Would you please tell the person closest to you, what is this called? Who do I want to pick on? Ethan, what's it called? What is this called?
You mean negative 2b squared minus 4?
Yes. What's the name?
Sorry.
Owen, could you help him out?
Quadratic binomial.
Okay, what is it, Ethan?
Quadratic.
Quadratic. That's a tricky one because it doesn't really sound.
It sounds like 4.
Yeah, it sounds like 4. But it's a quadratic trinomial. Okay. No, not trinomial. What am I talking about? Binomial.
I
2.
knew it was a binomial.
My bad.
It's a trinomial because
See, you guys, I figured that within these 4 days I've forgotten how to teach, so just bear with me. Second one here, go ahead and combine those like terms. You do not have to distribute a negative, so you could just mark it up as it is right now. Go ahead and do that. Check with your partner. See what you get. Ellie, what did you get when you combine like terms? Anybody see something they disagree with? Aaron, what should we change?
Wouldn't the second,
Instead of what?
wouldn't the second one be a power of 2?
Yeah, so this one should be power of 2 because we're not going to add our exponents. We're just going to keep our toppings on the hamburger the same. We're going to combine our number of hamburgers if you want to think about it like that. So common mistake, not a big deal. Does it look okay now? Okay. And what do we call this? Julian, go ahead. Yes, indeed. Neat. Let's see. Catherine, what's my GCF? Yeah, I might do negative 5x because you're gonna see me do that a lot later this week, or I guess next week, more like next week. I'm gonna take out a negative 5x because I want my first term to be positive. And so that would leave us with x cubed plus x.
No, minus.
Is it minus x?
Yeah.
Thank you. Minus x, because we have to end up with positive 5x squared minus 1. There you go. I'm going to take out a negative 4, just so my first term is positive, but 4 is correct.
But your first term would be positive.
It would not be. Why is that? Rearrange it real quick. And then I would go ahead and take out a negative 4 to make that first term positive. Okay. Check my math. Remember, we multiply the normal numbers together and we add our exponents. So that r in the 3r has a power of 1. Finish what you have and then check it with mine or with your neighbor. Easiest to probably do this by going from the binomial to the trinomial. So I'm going to start with negative 4v. Because that'll actually give me my largest exponents if I start with that one anyways. So negative 4v, v squared, so negative 4v cubed. Okay, so now we're going to multiply by negative 2v. And 7. Remember, you have to do each term to each other term in the other parentheses. So now we're going to do this negative 7. Oy. Emily, what should I do now? Yes, I should. I don't see any other v cubes. V squared v and one of the 49s. Yep. And what would this one be, the one to the left? Colby? Binomial, yes. Two terms. Okay, last few things here. This is what we did most recently. Factoring, remember our goal, we need to get two numbers that multiply to the C term, the constant, the one at the end with the outer variable, usually at the end. And we need those two numbers to also add to the B term, so the number that's in front of the variable with a power of 1. So on this one, we are looking for two numbers that multiply to 28, but that add to 11. Tell your partner, what are those two numbers? Let's see. Keely, what are my two numbers? 7 and 4. So this breaks up, remember, into n plus 7, n plus 4. On every single one of these, you can check and make sure you're right. Yes, Hafik? Two numbers that multiply to negative 18 and add to negative 3. Talk to your partner, discuss. Or what are those two numbers? Do you know? Yeah. So that would be then b minus 6 and b plus 3. You don't have to do the little x thing out to the side, but if it helps you, do that. Next one. Multiply to negative 50, add to negative 7. Discuss. Very good. Thank you for taking the time, though, to think about it. Remember, we don't want to be those people who assume, if I have trouble with it right off the bat, well, it must be prime. No, do not assume that. Be careful. Maybe you just need to work on your multiplication facts. Okay, but that was not the case in this one. Oh, no, look at this. Okay, take a look at it. On all these three up here, there is not a GCF. Is there a GCF right here? Yeah. You betcha. Write it down. Guys, what's my GCF? 4x. Which would leave me with x minus 10. This is a perfectly acceptable way to factor. So when I say factor, this is factoring. That's totally okay. You got a monomial times a binomial there. That works. Okay, next one. Check for a GCF. We need all three terms to divide by this number evenly. What would it be, class? 2. And let's go ahead and divide that out. P squared plus 6p minus 40. Now we're going to pay attention to this part. So pay attention to what's inside the parentheses now. We're going to factor that. So we're going to pretend like our GCF isn't there, and we're going to ignore it, and we're going to factor what's inside the parentheses. So we need, you know how to do this, we need two numbers that multiply to negative 40 and add to 6. Discuss. What are my two numbers? DJ. Yep. Wait. Negative 4 and 10. There you go. So it's going to be 2p plus 10 times the quantity p minus 4. To answer the question I think some of you are asking, do you have to take out a GCF first? The answer is yes. If you see one, if you know what it is, if there is a GCF, you have to divide that out first. Otherwise, it's not fully factored. GCF is part of the process. Last one, is there a GCF? Nope. So we're looking for two numbers that add, dang it, multiply to 42, add to 13. Discuss. Lauren, what are my two numbers? Negative 7 or positive 7? Yeah. So it's going to be v minus 6 and v minus 7.